I'll test run that anyway for right now. And then, cool. Do you want to get started on like the straight to the homework, or do you have questions about like?
I don't understand any of that.
Essentially, what it is you're just like looking at. It's basically like memory work, and what Professor Vargas was doing is he was kind of showing you that how to, if you don't have it memorized, how to figure it out.
Oh.
So it's kind of like.
So it's how to memorize that, like get flashcards and such.
I personally think yes, because like it's just gonna like cut a lot of time out, because you can spend a lot of time figuring stuff out, and I think that can be good. It's good to know how to do that, but also like me, I did straight memorization. I just memorized a bunch of stuff. Yeah, because I had a teacher that was like straight up like, we actually started the semester with all of our identity, the entire unit circle and all of our identities, and she just goes, memorize this. And yeah, and so I went, okay, like, and because she heeded a warning. She was like, this is gonna be crucial. So I took it to heart, and it's paid off a lot. Like I'm also doing math, so it really paid off, or engineering, so it really paid off for you. It will pay off, like just for the sake of the course, honestly. And it's really once you see the connection of everything, you're going to be like, I'm really kind of like looking at the same thing almost all. You know what I mean? Like so. All right, let's. I think probably starting off with the homework is probably. We can. Well, actually, let's just hit the identities first, and then I'll kind of let you know, and then I'm gonna kind of. Hopefully, I don't know if this thing is working. I'll try to cut it out. So, okay.
Add more chicken. I don't want to add more chicken.
Let's see. Yeah, okay, that's nice. All right. So essentially, like memorize, like your trig identities. These are your Pythagorean identities. Sine squared plus cosine squared is equal to 1. And Professor Vargas was showing you how to figure it out. I think it's not too hard to just kind of go ahead and memorize these. I think it's going to help you out with like calculus. And if you just kind of and then just be able to move those around algebraically, like, right? So it's like you could say this is also the same as saying sine squared equals 1 minus cosine. Like if you just move the cosine over here, you see what I mean? So really out of these 3, you can generate 9 total.
That's a lot.
Right? But it's really not, because it's really only 3 that you're just moving around. Right? That's really what's happening. You're just moving these around. So it's like, so, if you were to like move cosine over, then you have, is this a good one? Yes. Okay. You could move the cosine over, and you would end up having sine squared theta equals 1 minus cosine squared theta. Right? So that's just an example. You're just moving it around. So I would memorize these, or what Professor Vargas was doing is you could only know this one, you could just know this one, and then you divide the whole thing by, okay, yeah, so if you divided everything by sine or cosine, it generates those. That was his point that he was making earlier. So you could just memorize this one and say, hey, like if I divided everything by sine squared theta, and sine squared theta. Anything over itself is 1, right? Anything over itself is 1, so this guy ends up becoming 1. And then cosine over sine is an identity. It's a quotient identity. Which, do you know which one that is?
Over sine is cotangent.
Yes, it's cotangent. See how we're generating cotangent right there? See, that becomes cotangent, and look, 1 plus cotangent, and then 1 over sine squared.
Is cosecant.
Cosecant squared. Remember, don't forget the squared. But and the only reason why I say that is you could get used to saying cosecant, and when calculus comes around, you write cosecant without the square on it. You know what I mean? It's kind of like math. It's almost like math is so much about being exact. It's like match it up. You know what I mean? Like if it's squared, just go ahead and say it squared too. It helps. Or at least I think it helps. You know what I mean? Anyway, so that's all that Professor Vargas was kind of reiterating, is you could really derive everything just from this first line. And so now if you erased sine and you divided everything by which one? Cosine. Then guess which one you generate? If you divide it by cosine squared, that one would end up generating sine squared over cosine squared, quotient identity, tangent squared, and then you'd have anything over itself, 1, and then secant squared, and then of course addition, you can move it around and you get that. So you can go, I'm gonna try to record these because I know like some people have family life stuff or whatever, you know what I mean. So I don't know if this will be an experiment. I'll try to record this, and then I think I may do like an unlisted YouTube or whatever. It's not listed, and just send y'all the link or something.
Sweet.
And then that way anybody can look at it. Just erase that. But oh, I forgot that.
Are we working on the homework?
Well, first we were just kind of reiterating like the identities and
Mr. Vargas? Oh, I know.
It made it so complicated. It's just like, okay, guys, so this equals this. Now, if you think about it, think about it. It's just like I can't think about it.
Yeah, and it's really, really like this whole unit is really like how well do you know your identities? And since you're going into engineering, it's like just know them like the back of your hand. I would say I would go to a step further. Like you can figure them out. I would challenge you, just memorize them, just learn them all. You know what I mean? Like in like
Like you're talking about like the radians for each degree.
I'm talking about your identities. In that, I would say, yeah. Like, I mean, if you're going into engineering, like, just take it the next step. Because, that's probably why they teach it like they do is if you're not going into engineering, it's not necessarily completely useful to know this that well. But if you're going into engineering, I would say, hey, just like, know your special right triangles. Know the unit circle, know all your Pythagorean identities. How we read this one. These are the main ones. And all we did just before you came in here was just emphasize how he was getting these from this one. Technically, I think you should memorize these 3, but technically you can just memorize this one and then derive those from this one by dividing the whole thing by sine or dividing the whole thing by cosine. It'll generate those 2. And then you can just move these over algebraically to get different identities. Like you could say 1 is equal to secant squared minus tangent squared, right? You can just move the tangent over. Mm-hmm. And I would actually encourage y'all, I don't know if, like this will help in calculus, I promise, but if you close your eyes and you imagine this identity, and then just move it over in your mind's eye. If I said, what does sine squared equal if you move it over? And imagine moving that cosine over and go, oh, it's 1 minus cosine squared, right? Like, imagine moving these trigonomic identities in your mind. I think that really actually helps. Because you'll use them in their different algebraic forms like all the time. And also, y'all going into calculus, these guys are forever intertwined forever. You'll see some calculus identities, and these guys are always partnered together, like forever, cosmically, like they're always connected. So these are like just kind of like, that's all we were kind of harping on. Oh, let me erase this old stuff here. Old tools, we don't need these anymore. Or well, actually, you'll need these you need everything you learn. Bring it with you. For sure. Okay.
Yeah, he's asking if it was 30%, like triangle, like I have to like see the triangle, like draw it out first.
Yeah.
By measuring it.
Yeah, like, and for some reason, the triangles don't stick in my head at all. The unit circles, for me, works. So it's kind of just whatever seems to stick, you know what I mean? Like, it's, because I don't know, the special triangles just don't stick in my head, so I don't think of them as the triangles that often. Because I have to do the same thing, I have to kind of write it out. Okay, do y'all want to, do you have any more specific questions from, like, today's lesson, or do you want to try to hit some of the homework and, like, because,
I think hit the homework, 'cause
yeah.
that would probably go over what we did today, like essentially.
Yeah, and I think I have some like recommendations for the verification thing. Because as you saw, I mean, you can literally write, you could literally write 5 pages and get nowhere, like with the verification. So it's like, I mean, you literally can. Hey, how's it going, dude? Yeah, you can like, and so it is from kind of like helping people, just call it that, helping people in the past. I have, like, there's an overall concept, and it was kind of what Professor Vargas said. He went from like the more complicated one to the easier one, like from what? Let's just start working on one, and it'll make it.
We're starting on homework?
Yeah, we can start on the homework, which it looks like. I mean, there's not much, right? There's 5.
There's 5.
No way. There's no way there's 5 on the homework.
Is that it? Oh, you know what? I wonder if I didn't download the whole thing.
No,
That was the last 107 points.
There is 5 on the homework?
Is that it? Is that really it?
Question?
I swear it was like 100. Holy cow! I was about to say.
I would think it was more, but trig identities. We got a trig identities, and I don't see where he has posted the worksheet.
It's on week 2.
Week 2, thank you.
Hmm.
Okay, maybe.
No, it's more than 5.
Okay. Oh yeah. Okay. So I didn't open the whole program. I just saw the front page.
118.
Oh my lord.
Okay, great. That's good. Yeah, there we go. I see. Okay, great. All right. Well, you all want to just start tackling the homework then?
Yeah.
Yeah. And I'll also notice, like, probably I'm just gonna say, like, whatever your grade was for the test, if you saw that in relation to how much of the homework you did, right? Like, versus, like, if you didn't hit a lot of that homework, that grade's probably going to go down. Because, like, everything is actually very beneficial to know. Once again, especially for engineers and people going to at least Calculus 1, this really is going to help. So, I don't know, do y'all want to just start at 1 and, like, and move forward? Okay. And then I think verifications can be just us working through it together. I've noticed that a lot of people have these like, oh, I never thought to do that, or like, because you can literally go almost like it feels like an endless amount of ways to do this. So on one we have cotangent of x. I'm gonna put parentheses because to me it's like it just frames it out better, and it really looks more like it's a function with something inside of it, which is what it is. I like, that's just me being picky. And then, okay. All right, cool. Once again, there's lots of ways to go. But name of the game is how much do you know, how well do you know your identities? So that sheet that he gave you, like, really good to quiz yourself on that. Start making flashcards. I have a digital set of flashcards that may not look the best or whatever, but they're kind of already made out in a PDF. They'll be unfortunately they're big, but you can scroll through them on your phone or something like that. That may help. I'll send those to you. Okay, so what's your first intuition?
Cotangent is 1 over tangent.
Cotangent is 1 over tangent, correct?
So it would be 1 over cosine squared times tangent equals secant squared over tangent.
Say that one again for me.
I don't know what I just said.
Okay, well, I'll write it out. Okay, so what it is like, and I'm gonna say this, like, your reciprocal identities, get used to this motion, okay? This will really help. Cotangent, if it's in the top, if you reciprocate it down in the bottom, guess what it becomes? so get used to moving, they call this the line of demarcation. Get used to this motion down. If I just move cotangent down, I have 1 over tangent x, right? And cosine squared now. I just moved it down. It just moves down and changes. Because I'm going to try to get you to this organic place of moving these around, right? Like, it's almost like we're getting in the, like, as far as like if you play music or whatever, it's like a music theory thing. You just got to get in the weeds and play until something sounds right. So this is kind of how that feels. So moving cotangent down is tangent just down, right? Well, guess what? What's cosine if I just move them across that line of demarcation?
Sine?
No,
Cosine, secant?
Yeah, so guess what? Bro, it's already done. Like, that's how quick it is. You just move it up. So this is secant squared over tangent x, we're done, equals 1 step. So I'm going to try to get y'all into 1 to 5 steps every time and kind of build that intuition of how to move. Do you see how we're there already? 1 step. Because you could just realize, oh, secant is its reciprocal. It just moves across the line of demarcation and becomes secant. Cotangent is tangent when it moves across the line. So I literally just flip that like a coin, and it becomes this. Like, you don't even have to do this step. You could go, oh yeah, I see that those are the same. I just flip it. You see what I mean? 1 step. Okay, so get used to seeing that. You're going to use reciprocal identities all the time. So just get used to the reciprocal whenever you move. If cosine is down here and you move it up, it just changes to its reciprocal. Just get used to that feel, and it'll make these like kind of start cranking out. That's one hint right there. So we already have our answer. That's answer for 1. These are gonna probably ramp up.
Wait, so that's what all we're doing?
Yeah, because what we're doing is we're proving the left side is the right side. They call these verifications or proofs. Like, I guess in Trig they tend to just call them verifications, because you're not really like, I mean, you're proving it, but you're just verifying, hey, these two things are equal, you know? Okay, so that's 1. Any questions there about that? Cool, right on. Yeah, but get used to that feel. That it will make things a lot. It makes it more intuitive how it feels, I think. Now, number 2. Yeah. Okay, we've got. This might be one from, but we can just read it. This might be from class. I don't know. He did one similar to this. In fact, actually, yeah, he did do this in class. He did this in class. But I'm going to actually show y'all, I'm going to go a little bit of a different way than what he did that's a little bit shorter. That might be a little, or at least I think it's a little shorter. Okay, so also, how do you know what identity to choose? Because whatever you choose at the very first is either going to send you 7 pages or 1 step or 2 steps, literally, right? So it's almost like we're playing chess. In chess, you think as many moves ahead as you can. That's what we're doing with verifications. So, and the idea, the main idea, in my opinion, is it's easier. Most of the time, it's easier to go from big to small. Like if you were making something condensed or whatever. Not always. This case is going to be a little bit different, but okay. So, what do you know about the relationship between cotangent, cosecant, tangent, secant? What is like in identities wise? The most closest relationship. Sine and cosine. See, I would suggest not going that route. But you can. I want to show you the most efficient, because you certainly can, yes. You could change everything into sines and cosines. Okay, actually, here's a rule of thumb. I usually do these like, okay, so you always want to go from big to small. These are almost even, so this one doesn't really, so big to small. When all else fails and you don't know what to do, turn everything into sines and cosines that you can. And it really starts turning everything into Don't always do this, like, because you can make it harder. You can almost always solve something if you just break everything down into sines and cosines. Because cotangent squared is what in terms of sines and cosines?
Cosine over sine.
Perfect. Squared. This one is
Sine squared over cosine squared.
right. This would be
I don't know these.
1 over sine squared, right? And this one would be
1 over cosine.
yeah, so you could break them all apart, common denominator, move a lot of stuff around. It's going to take a little while, but that will solve it. Like, I recommend, like, go straight, think Pythagorean identities, and this is why I say, like, you know, Professor Vargas was like, he was only having you memorize one and you could derive everything. I actually highly recommend memorizing the first three, which are the sine squared plus cosine squared equals 1. Memorize this one, then memorize 1 plus tangent squared theta equals secant squared theta. Memorize this one, and then memorize this one. And and you'll see why whenever we're looking at this, how much it's really going to help if you have at least these three memorized. Because then you look and you go, hey, on this problem, what is the closest relationship that you have? And this comes up all the time. But if you only have this one memorized, and you have to figure this one out every time to get these, it's going to make these way longer. Does that make sense? Because if you look at these, you see that's what I'm talking about. These are the closest related identities that cosecant to cotangent looks like, and secant to tangent looks like. Do you see that? They're forever, what's that?
Yeah.
Yeah, they're forever intertwined. So those are good. So now, like, what you can do is you can just replace it. So if we come down here, so I'm going to do the right side here. So check this out. If you have cotangent squared x minus tangent squared x, what do I change cosecant squared by itself into? What can it be?
1 plus cotangent.
Perfect, yeah. And so now we have this 1. I'm going to put it in parentheses. I like doing this because, we're doing x's. Sorry, x's in this case. I'm going to put it in brackets to let myself know, hey, this whole thing is equal to that, right? And then secant becomes this guy, right? 1 plus tangent squared, and we're doing x's, right? Like this. Okay, look, we're all in the same terms now, in one step, right? Now, all you do is algebraically clean this up, and if you can already see what's happening, we're already done. One step. This is the power of, like, knowing the closest relationship. When you start seeing these, you should, like a computer, you're going through until you hit, like, something that has elements of things in the left and the right shared in common. And that will cut, like, because in class we went, like, the wrong way. He did it on purpose to go the wrong way to show you how long those go, and to start getting you to think about, you know, because he changed that sign where it wasn't true, and he just kept going and going. Okay, so now when you clean this up, you just have 1 plus cotangent squared x minus 1, that's a 1, and then that minus distributes, correct? X here, the 1's canceled, we're there. Cotangent squared x minus tangent squared x, and you're done already. One step. See what I mean?
That's a lot of math. It's a lot of writing.
Well, it is. Yeah, these are a lot of.
Isn't it just pretty much like plug in? You just
Yes.
Plugged in like
It's
those values into the.
Yeah, it's a puzzle. It is all it is, and they can get a little more complicated depending on how big. Because some of these can get wild.
Mm-hmm.
But like, own these for verifications. Own these. Know your reciprocal ones too. Like, this is the relationship of 1 over tangent squared, right?
Mm-hmm.
Like, so if you know your reciprocals and you know your Pythagorean identities, you're gonna crush these. That's it. That's about as much as you really need until they get a little bit more complicated, and you can really crush these hard.
I think I finally noticed on the brackets like that made it more.
Yeah, because you see it transforming. You see it transforming. I recommend doing that me personally, because you're keeping that thing as a whole, and it helps you carry the signs over. Like if you don't do that, you could distribute your negative signs. The thing that's going to kill you in calculus, when you ask people, there's a running joke, what's the hardest thing about calculus? Algebra. And I'm not kidding, like, because you literally do 1 to 2 steps of calculus, and then it's just algebra the rest of the way. I'm serious, yeah. So algebra never leaves you. Okay, so are you all good here?
Yes.
Awesome. Cool. I'm gonna erase this and make it. We'll kind of do like another tools kind of idea. So these are important. I'll kind of leave those there. All right. So number 3, we have. I hear that. You're like, right? It's coming. But it really is, when they settle in, it's kind of like a euphoric feeling almost. You're like, whoa, I'm speaking another language right now. And we're like talking about things that are rotating in space and stuff. Okay. Sine squared x over cosine of x, like that. All right, right on. Okay. So big to small is usually like one thing I like to do, break up big stuff into small stuff. Usually when it's like a quotient over each other, it's kind of like you skip that step, right? You're not necessarily breaking it. So now you're just sitting here thinking like, what are the closest relationships that you can draw out of these? And again, there's really no right or wrong way to go. It's kind of like sine and cosine.
Like there's a lot of sines and cosines. So like you can transfer. Wait, maybe not.
Yeah. Okay. So now, so when you see squares, you should automatically you should have this thought in your head. Okay, squares make me think of Pythagorean. There's a Y in there somewhere. I cannot spell. I want Pythagorean or whatever. I can't spell. Someone help me. Pythagorean, but this, I'll put P, Pythagorean identities. Okay, and then when you see these quotients right here, you automatically should think in reciprocals. Reciprocal. I'm not an English person. You should, so those two things should come into your mind's eye, reciprocals and Pythagorean identities. So all right, so, and sometimes you just have to start doing stuff to break something loose to see if a pattern stops. Because you can get caught up trying to think so many steps ahead. Sometimes just move the pawn out, and watch what happens on the chessboard, kind of thing. So what do y'all want to do first? And we'll kind of just go that way.
See, I will look at this and just work at it. I don't.
Yeah, you're not sure exactly where to.
No.
Yeah, and that's not a bad thing. Yeah, sometimes you got to do that. I had to do that a lot. I would spend every weekend. I would spend extra hours, and I would do both sides. I would on every problem just to get good at them. I started working both sides to help. I'm not saying do that, but first I would say, hey, what if we just get rid of the quotients and see if anything happens, right? Because fractions are ugh. So if I move this across the line of demarcation, what does it become? Yeah, tangent squared, right? So we have a tangent squared x and a cosine x. And then let's just do it on this side. What would I get if we move cosine across demarcation?
It would be secant.
Yeah, so I'm going to go secant squared and cosine. Sorry, secant. And I'm only doing this to just say, hey, this is a thing you can start and go, hey, is that better or worse? Huh?
No, I was just laughing.
Okay. Oh yeah. I'm actually going to say don't go this way, right? Because nothing really looks right. It doesn't look like anything. But check this out. This is another trick. Anytime you see squares, watch this. Anytime you see something squared, I'm going to encourage you to do this. Break them up into two of them, right? Because that's squared, right? Watch, and you'll see why. sometimes, because look, I'm breaking things down into simpler things. You see what I'm doing? I'm kind of breaking things apart. What's sine over cosine? Tangent. We have a potential tangent on this side, right? So like I can take sine over cosine, and well, we won't do that quite yet. So if we go over here and we have cotangent x, here, one of these signs can become tangent x. Oh wait, we should do one. I'm doing both sides at the same time. We shouldn't do that. That's bad. That's bad. Hold on. I'm gonna back up right here. We're just gonna do the right side with the signs. We're gonna keep the left side the same. Okay. But you see what I did here? Because this is like saying sine over 1 and sine over cosine, right? So one of them can be tangent and sine. Okay. And so now we're going to keep this side the same. So now what we're doing is we're trying to manipulate and get something closer to this. So what could we do on that left side? Like let's say, or wait, say that again.
Bring up cotangent up and make it tangent in the numerator.
Right, but let's actually, I was thinking on both sides. Let's just do the right side. How do I get this closer to this?
Tangent to cotangent.
Yeah, move it down across the demarcation. So now you actually have sine x over tan x. Or sorry, cotan. We're getting closer, right? So I'll restate this one here on this side. And then sometimes as you go through these, you can start getting close. So now we're right here. What could we do? Like we're going to leave this side alone. What can we do to this side to make it closer to this side?
Square it.
Wait, what?
Square it.
Almost. We need to get a square, but we have to only affect this side. What can I multiply by that doesn't change anything?
1.
1? What can 1 be?
Cotangent over cotangent.
That's right. And that gives you a code, right? You can say cotangent, bro, this is where it gets awesome. We're like, this is where the power of multiplying by 1. Now, look, we're one step closer, right?
Mm-hmm.
To the edge, and I'm about to break, right? Whatever that song is. Remember that song?
You did it to the other side too?
No, because we're the idea is to take one side and see if you can do a Rubik's Cube type thing to make it match the other side. Ideally, you want to pick one side, go front to finish, and then you could always go back. Sometimes if you get absolutely stuck, change the left side a little bit to see what step, but try to refrain from that. It will make you better if not. So we keep this left side the same, and this is a huge power. So kind of in these steps I was thinking, you're breaking things down, you're using Pythagorean identities. Multiplying by an interesting form of 1 is one of the most powerful things you can do in math. Anything over itself. You're going to see that all the time. And that's like, you got to make it work. That's what the 1 is. Multiplying by 1, you make it work. That's what I like about that. Okay, so now we have sine on this side times cotangent of x over, now we have our cotangent squared. We're almost done. Boom. The bottom, leave it alone. We got it. You don't got to do anything anymore. Done. Okay, now, how do I make this into cosine? And you see, you're starting to, and it's almost starting to force you into a certain way of thinking, right? Because what would you use to modify this? What's the only thing you can use? There's no squares. What can you use? The only thing.
I don't know.
So, and let me. So we're going to kind of put like a box, like a tools here. So these are our Pythagorean identities. Then we have our reciprocals, where you have sine theta. Well, if we're using thetas, I won't use, that's the only time I usually don't use parentheses, theta, because it's like kind of standard. So you have your reciprocal identities, right? These are your next kind of sets to know. I keep doing that for now. These to learn to use. You got these guys. I'm only going to write the ones because you can figure out the reciprocals of the other, right? So we have these. These are one things you use, but then the other one, the very last, these two things, and their reciprocals. These are how you solve the rest of them. What's the only one that you can use? If you don't have squares, you can't do Pythagorean identities. You can't. So what are you left with? These. What's cotangent? If I split it up.
Cosine over sine?
Yeah, it's cosine x over sine, right? Is what this becomes. So I'm going to cross this out. Sine, this right here is really a sine x over 1, isn't it? The sines cancel. We're done. Do you see? See what I'm saying? I want this to be in your brain. Like I don't want you to figure them out. Like you can, but you see if these are readily available, you're like looking at this and you go, oh, I could just split it up, done. And we didn't go that many steps. We went I wrote out my extra steps. We went like 2 steps, something like that. This is going to unlock the potential. Just these 6 things and their reciprocals and stuff like that. But I would say don't just know this one and derive it. It's just not gonna, it's like you're not putting the right gas in the tank. You know what I mean? You're gonna be slower. It's gonna take you longer. Guess what? You're gonna be more frustrated as the math homework gets ginormous over the years, especially for engineering students. And for you, pharmacy, you're gonna be doing like science. It's just we're getting into a field where it's like we're working 8 times harder than anybody doing any other subjects. You know what I mean? You can blow off English and make like 100 at the end of it because it's like subjective, right? This is exact. You got to actually know something to do math and science. It's not garbage. All right. So okay, awesome. Do you want me to finish writing that out? But y'all see how that became cosine over cotangent squared?
So you took what cotangent equaled to get rid of the cotangent, right?
Say that again?
So like cotangent of x right there, like where you crossed out, you just crossed it out and put it cosine over sine.
Yeah. So this is what I did it kind of fast. Sorry, I get excited on these. So what we did is we got this one, and then these combined with sine. I'm gonna leave some space so you can see what I did. So what I did, and I literally feel like this. I feel like I came in here with like an axe almost, and I went, and like this guy, I turned it into cosine. Oh, we're doing x's over sine, right? That's what this is, right? So I don't have that anymore. This is the same as if I just wrote it as, right? What's in the top and the bottom, they can cancel. They canceled, and I'm just left with cosine over 1, which is just cosine over cotangent squared. We're done.
I see.
You see what I mean?
Mm-hmm.
Yeah. So it's kind of like, think about it. This is the feeling, the organic feeling I want you to have. Moving across the line of demarcation just changes its reciprocal. You can take any one of these and split them into these guys. You can. I think of it like, opening an orange or something. Like you're opening it up into something more, you know what I mean, to work with. That's kind of what you're doing. You have a bigger part that you're breaking apart. You got more parts to work with. You're breaking stuff loose to get to where you're at. And then you have to and really these are practice. Just started seeing these. They're just practice. They really are. Okay, are y'all ready for... Do y'all have questions? Do y'all want to jump around, or do you want to keep doing these? Do you want to try one on your own?
About how far with what we did today is where we're at on the homework, or what? Today
you're heading to because we could skip before it gets too late. We could skip to the other stuff. So we're getting a nice. Really, I hit all what verifications you need. These are what you need. I would suggest having these, not figuring them out. I only recommend it just from experience. But if you don't have them memorized, write them out on your page like Professor Vargas was saying, and then you have something to look at. Like write them out and be like, that way you don't have to have them in your head necessarily. We went to, so he went up to 13, 15, 17, 17, 19, 20. Well, like technically on the homework, we went from what he did in class today would get you all the way up to 53. You should be able to do all the work up to 53 just from what you learned today on the homework. Well, welcome to your STEM career.
I'm so excited.
It gets better, and you feel proud of yourself whenever you learn this stuff. You really do. Like, you come through here and you're crushing this, you're walking around and you're like, I know something that's pretty neat, you know what I mean? Like, that's actually going to make you a living. Like, you're not going to spend 4 years at a university, get a music degree. I have a music degree, I'm not trashing it, but I'm kind of trashing it because it's going to get you almost nowhere unless you're just amazing, dude. Anyway, do you all want to skip to the next thing? This was a nice thing on verification, and then we can go straight into, it looks like 11. Do you want to start there? And we'll start hitting the sum of differences. We'll add to this thing, list of stuff. Cool, before we roll out. How late is everyone planning on staying?
I'm leaving at 7 and I'm ordering my DoorDash at 7.
Nice. How about you guys? Staying late, just kind of whenever you're just wanting to, you're seeing the importance of getting ahead or staying on top of it now.
Yeah.
That first exam lets you know.
I'm
It lets,
getting tired.
I did better than I thought I was going to do.
that's awesome. That's sick.
Drove back from Weatherford again.
Dang.
It's the last time though.
Do you have family up there? Is that...
My girlfriend's up there.
Okay, I got you. I lived in Denton for a little while. I had a girlfriend in Lubbock when I first went to college, so I get it. Okay. All right. Right sign. Let's hit some of these. And we can at least hit something conceptually for Layla before she rolls out.
How soon do you think you'll have this video posted?
Immediately.
Immediately?
Yeah. Well, I mean, I'll get home and mess with the technology to figure out how to do, like, I'll have to make a page and do an unlisted, and I don't know how to do that right. I don't think it's gonna be very hard, but okay. But yeah, I can start if the recordings end up being worth anything, I'll do like an unlisted that only you guys can see, and then I'll do, I don't know how much I'll like look back over this and try to timestamp something. I might not, so you just scroll through it fast or whatever and put a timestamp for other people or something. Yeah, so now we're talking about sum and difference identities. Can y'all just like state what the sum and difference identity is? What this is? Does this pattern look familiar to anybody?
Sine alpha plus beta.
Yes. Awesome. Did you all catch that? This is equal, so we have sine, I'm just gonna say alpha plus beta for general, this will be like our general, and this is always gonna expand on the right hand side is an alpha, a cosine beta. Usually I don't always goes with my cosine alpha, right? And then sine beta. Okay, so notice that there's a couple different ways to look at this. You can do the jingle, sine, cosine, cosine, sine, same sign. I don't like that, but that's what some teachers will teach you. I see it like a reflection. I see this. I see like that's a mirror, and I see the cosines, and then I just remember that the angles are in order from left to right. That's just how my brain works. So, you know what I'm saying? Like, this is the cosines and sines are reflecting across the sine, but then I just know alpha, beta. That's how I think about it. That's not necessarily I don't know if that benefits anybody. But I liked what Professor Burrell, I really, really like that. Did y'all catch what this meant when he did that? Did y'all catch what that means? Well, yeah, but like in a theory book, if you just, because this is how they write them in math books. All like let's say I do this so you can just see it in a different way. What if I wrote, this won't be correct, but it'll be like, it'll make the point. Okay, what does it, if you see plus minus and then minus plus, what is that telling you to do? Yeah, if you see a plus here, there'll be a minus here. And so if it's the same, then if you see a plus here, it'll be a plus here. It just means flip them or keep them the same. This is how theory books write it. So that way they don't have to write two formulas. They write one formula and just say, hey, it works like this. So you'll be seeing that in, you probably will too, doing STEM. I mean, you'll just see, because you'll be looking at math books, you know, too. Physics and stuff. Okay, anyway, that's what that is. So, so what do we do? First, you just make sure it's in this form, right? Are these angles the same? Is everything the same essentially? Yeah. So then you can turn it into that. And I mean, I literally, for me, like it's very spatial. Like when I see this stuff, I literally see it moving. So you know it's going to be sine, whatever your alpha is, your alpha plus whatever your beta is. And so what does that simplify to? Yeah, negative x. And I'm going to take you one step farther. What does that also equal? One more identity to know.
Negative sine.
Yeah. And what is that called?
Odd.
It's odd. It's an odd function. So either answer is correct. Is my point. Because you'll see it in different ways. You may end up using these sometimes.
Where did the cosines go?
What's that again?
Where did the cosines
Where did they go? The red is your formula.
Yes, but where did it go? Okay.
Yes, okay, yeah.
You just did alpha plus beta, so.
So this
That's what we're
that's
looking
like
for.
an
is this, right? It's equal to this. So the cosines, they disappear. And it becomes this sine identity.
Oh.
So you're going to see a lot of this. Get used to that. So this is one thing you need to add to your list over here to know is your sum and differences. So it's like you need to know and that equals, I didn't leave enough space. Well, I'll probably write it down here. But
So the plus or minus depends on if beta is a negative number, right?
yeah, well, and you could move it around, right? Could I move this one here and that one here, and then it's a minus in the middle, and then I use minus there and switch the angles? You can. It's relative, right? So like get used to that in trig. It's like you're basically, am I looking at it like this or am I looking at it like that kind of idea? Just like with the triangles. That's what's happening. It's literally the same. You just have to know what, you're adding a negative number, or you can say 2 minus 3x.
Mm-hmm.
It's kind of like, Cool. Okay, so know this guy, all right? Answers right there. Let me see. We could jump. Oh, and then he did 17 in class. Let's do 18, and then that's about time. It'll be time for you to roll. Okay, so know this guy. I'll write it over there in a second. So 18 sine 17 pi over 12. Nice. Okay. And what it's saying is like, you could plug that into your calculator, right? And get a number, but we want an exact number, which means fractions and radicals, irrational numbers, right? And stuff like that. So the only way you can do these is turn them into, there's only, in this case, we're changing them into two angles that make sense, is really what it is. So we're turning them in sum and difference is the short of it. So 17 pi over 12, and I really, really liked what Professor Vargas did here, where he said, well, first let me ask you, do you know what quadrant that's in? Yeah, like intuitively kind of do you remember if we were looking here, pi is anything over itself, so if you had 12 pi over 12, that is pi, right? Mm-hmm. So is that more than that? Yeah, it's more than that. And then over here would be 24 pi over 12, right? Because that's 2 pi, right? So is that less than that? Right. So it's somewhere here. And so you'd have to be like, this one, these are easier. That is harder to look at.
18 pi over 12.
Would that be this one?
Yeah, because it's just right to the left over. It's in quadrant 3 right from that.
Right, so you're just taking those and dividing the equal distance here and here?
Yeah.
Is that what you're doing? Was that 8, 7, 6? Mm-hmm. So it's 6 in between? Mm-hmm. Not 8, 9, 10, 11, 12. Wait, is it?
Yeah, 12.
6. Okay, you're right, yeah. Good. I didn't know that, so that's great. That's problem solving right there. Awesome. So it's here then. It's barely off of here, right? Mm-hmm. Right. Okay, awesome. So we're in quadrant 3. What is sign in quadrant 3?
Negative.
Negative. Awesome. Great. Negative. All students take calculus. You can think that. It's negative here. So should my answer come out to be negative? Yeah, that's one way to check yourself. I like to do those kinds of preliminary thinking because you're because you can get messed up in the algebra. So you come out with a positive number, you're like, oh, that can't be right. I know it's in the third quadrant, it's gotta be negative. Okay. All right, so and again, Professor Vargas, super awesome technique. Why don't we use a tool that we've had in our past so we can kind of understand exactly what this number is, right? We could just multiply it by an interesting form of 1 and get its number. Also, I'm going to let you in on a little secret. Anything that's over a 12 is 15-degree increments. You'll learn that one later. These are actual technically special angles, but they're always 15 degrees. So this is so when it was here, you know that's 270 minus 15. That's going to give you that angle without having to do this. See what I mean? Because they're 15-degree angles. So we'll do the math here. So 12 into this. What is that? I'm probably just gonna use that. We could spend our time doing algebra a little deeper. Was it y'all probably do this faster than me? What's this? I'm just gonna go. Let's say 17 times 180 over 12. 255. Right, which would be your. Right? So if you took 270, right? If we minus this, 6, 1, we get 5. Look at that, 15-degree angles. Every 12, if you see 12 on the bottom, it's going to be some kind of 15-degree angle. But this isn't our answer, though. I'm just showing y'all something neat. But what it is we know that our angle is 255. Okay? Anytime you see a 5, you're shooting for some kind of 45-degree angle whenever you're creating your sum and difference identity. So,
210.
What's that?
210 and 45.
210?
Yeah.
Oh, I like this. Yeah. Yeah, there we go. I like that. Yeah, no, that's great. Yeah. No, see, arithmetic for me, slow. Equations, all day long. I got she used this degree and that degree to get a sum and difference.
What degree?
210 and 45. If you just take a 210 degree, and these are essentially what you're doing is you're trying to think of special angles. This is why I think it's also good to memorize this, because if you know one of your special angles and you're trying to make it into a special angle, we can get an exact number. That's kind of the idea.
Are those both special angles? Because 210? Yeah.
Exactly. Because those two special angles are going to give us an exact number at the end. So that's exactly what you want to do. Yeah, so that's really the name of the game. You're trying to break it into two special angles that you know, right? Because what is 210? What kind of angle is 210? With the reference. Well, obtuse, yeah, but we're relating, when I say reference, I'm saying make it a first quadrant type angle, because then you know you have all yours memorized, right? And then you'll know what the exact number is.
30.
Yeah, so it's a 30-degree angle away from 180. So if you know what's the sine of, or we'll get there. Hold on, sorry, a second. So anyway, so we're gonna replace this now, and we're gonna say we want this to stay positive. So we're gonna say 210 degrees plus 45 degrees, right? And that's gonna give us that 255.
Mm-hmm.
Awesome. Okay, so now, and then this is when we'll actually do the special angle stuff. So then, what is this? This is a sum or difference identity. What is it?
Are you asking for like the equation?
Mm-hmm.
What's my equation? Sine of 210
Okay, sine of 210.
times cosine of 45
Beautiful.
plus cosine
Yeah.
of 210
Yeah.
times sine of 45.
Sick. Okay.
How much genius?
Sine, cosine, sine, sine. If you like that, I don't. Like, it's starting to stick in my head, and I hate it. I don't like that at all. Like I don't. I like to just see the pattern. Because did you know sometimes those mnemonic devices actually slow your thinking down? Like every good boy does good. Whenever you're reading music, actually slows you down because you have to go through a thinking process to see it instead of knowing it, just knowing it. Like that's kind of the same with this stuff. Okay. Anyway, so now back to my question. What is sine of 210? It's a 30-degree angle in the what quadrant? Okay, so what does a 30-degree angle give me? 1/2. It's in the third quadrant, so it's boom. Awesome. Times cosine of 45. These should be the cake ones. It's what is the special angle? Wait, somebody did you say? Go so without looking. Or look. I don't care. Look.
Lower 2 over 2.
Every time, so easy. What's sine of 45? Well, what's that?
I don't have these memorized yet.
Yeah. Well, I mean, this is the process, though. I mean, you will at some point. So guess what? That's why 45s are so good. Because okay, now cosine of 210 though. What is that? You just think reference angle. You already.
So it's pi plus the 30 degrees, right?
Well, you already figured it out. We said if the reference angle of 210 relative to there is a 30-degree angle. Mm-hmm. So now you think, what's cosine of 30?
Cosine of 30, square root of 3 over 2.
Yeah, and it's in the fourth quadrant, so it's, for cosine, negative. I also think, okay, now check this out. Like, remember whenever he was saying cosine and sine, or cosine is the only even function? Remember him saying that? Think when we had the all students take calculus, this side of cosine is positive and this side's negative. It's like even across the y-axis. That's another, it's not necessarily right, but it's like a way you can remember it for cosine. So if cosine's on this side, it's negative. If cosine's on that side, it's positive. Just overlapping layers increase clarity, just like that. So here becomes the square root of 3 over 2, but it's negative. And so now we multiply these guys out. Negative square root of 2 over 4. And that'll be a minus square root of, what is that on the top, right again?
6.
Square root of 6, right? Yep. And so if you just combine them, then you get negative square root of 2 minus negative square root of 6 over 4.
And that's your answer?
That should be our answer. Let's double check. I could make something.
It's
Yeah.
not as complicated as previously anticipated.
Yeah. I think Professor Ferguson nails it right here because I would spend so much time figuring out the fraction and then takes so much time. So I really, really love what he did here. So definitely take that with you.
Okay, besties. I have bed and gigs waiting for me, so
Nice.
love y'all. Good night.
All right. Coming out. Congrats on the test. You gotta put in the work. You earn every grade you get in math. That's what's nice about it too. You really are like, dude, I worked hard. Let's go. You know, it feels good, man. It feels good because it means a bright future for you. Mm-hmm. And that's like so important, man. Like I'm an old guy coming back to school, out in the real world. It's broke all the time. I'm getting there. Yeah. Cool, you're out soon.
Yeah.
Awesome.
I'm tired.
Well, yeah, I bet, dude.
I was just falling asleep driving here.
Oh man, pull over and like take 15-minute naps, dude. It's worth it. You know what I
I
mean?
was
To be
right
safe.
at the dot of like on time, you know.
Dude, be alive and late instead of also not on time and dead, right? Like you don't win either way on that one. So, people will forgive you. Be safe. You can.
Have a good day.
You too, dude. Congrats on the test, man.
Thank you.
Oh, dude, what did you throwing in the towel hat enough, or do you want to do a little more, or do you have any personal specific questions?
Not really, it's just trying to memorize all of them.
Yeah, like I promise you so much. If you put as much of those in your brain as possible, like this class, the frustration level of this class just whoa right here, because all of it is like people are struggling to remember these, and in my personal opinion, it's just you're gonna see them all the time. Just learn them, dude. Like you could just learn this one and derive them, but I just think, like me, I don't like to be frustrated, right? Like I hate that feeling. So in my experience, if you just learn, not all of them, but most of them, like they just take the frustration out of the work. It becomes a little bit more fun. You see the connections a little bit stronger because you have these readily available. And so if you're searching in your mind and you're like, okay, what's the closest thing like from cosecant and cosecant and cotangent, you're like what is the closest thing? You have to always come back here and and it's not always apparent, you know what I mean? Like when you have so much stuff going in your head and you're thinking about your life and there's stress going on, you know what I mean? It's like, just make it easier for yourself. You do a little bit more work and it will pay off, it really will. So any more questions? We can keep trucking along.
I just like one more problem.
Okay, do you want to do a different type of problem? Put a head down one? Really, I mean, let's do a tangent one, because those are, let's do tangent, because that'll kind of really wrap everything up nice of what you've learned today a little. And I'll start making another tools list, which is basically, it's just gonna be your identities, dude. It's that page, memorize that. Okay, sweet. Let's try, let's do 40, or let's do 39. Let's just start on the first one, 39. And we have tangent of 2 theta. I'm gonna put them in parentheses. I just like the parentheses. It's like grouping. It's like a visual aid for me. You know what I mean? It's like. And I just think being as meticulous as you can be, like on the page, it always, for me, it always seems like it pays off, because you can start thinking crazy stuff, and then if your writing is so on point, and you look down and you go, oh, I'm thinking something wrong, but you actually write something right, and it reminds you to do the right thing. I've had that happen a ton of times on tests. Okay, so can you just quote me the regular tangent sum of difference identity?
Tangent of alpha plus or minus beta.
Tangent of alpha plus or minus beta is equal to
Tangent plus or minus tangent, or tangent alpha plus or minus tangent beta over 1 minus or plus tangent theta. Tangent, or tangent alpha tangent beta.
Yeah, multiplied. No, it's not that bad, right? I don't think it's that bad. Nice. Okay. So knowing this, looking at that guy, just make sure it's in the right form. Make sure your alphas are all in the right place and your sines are right. So if you were to like identify this, you go, is this angle the same as this angle? Yeah, it is. Is this angle the same as that angle? Yes, it is. We have a plus up here and we have something opposite down here. That looks pretty good to me. So then you just take this and you into the smaller one. So you restate the problem. The alpha angle just boom, right? We know that the top one is the one that's dictating what's inside, or I like to think of it that way. So we have a plus, plus, and then we have our beta angle. And so if we just simplify down. Not bad at all.
So it's just recognizing what it is.
That's it. That is the, see, and you can see how it can be frustrating. If you don't do the work, guess what's going to happen? You're gonna hate this class. The work is gonna be super slow. You're gonna do something that's really simple. That I see so many people, they just don't do this little bit of extra work. Learn these, learn that, and they're like, I can't do trig. And you're like, dude, you can't sit down for give yourself like an hour for 3 days in a row. You'll crush these. Just get some flashcards. Test yourself, don't wait for the homework, while you're walking around and be like, sine squared plus cosine squared equals 1. I know that's silly, but it's like, if you think about it in regular, everyday context, it just becomes a part of your vernacular. You just know it. And then you're on your way to becoming an engineer and making good money, hopefully, and having a nice life, dude. Just gotta do a little work, get that cheddar.
And you said you have the flashcards,
Yeah, I can send them. I'll send them to everybody. I want to say I might have sent it to the wrong. I'll send it right. Oh no, I'll send it right now when we're talking. Oh, I don't forget. Trigonometry, flashcards, identities. This. Here. And you can, what's nice is they're in a PDF format where you just scroll through them. So the first card is in front of the card, back, front of the card is first, second. So it just alternates as you go down. And now that you're kind of familiar, you won't have a problem with that. So we're going to PDF these out. This will be Outlook. This will be Serve. Card, PDF, identities. Oh my goodness, if I could just spell better, I'm the worst. I'm almost illiterate when it comes to design. I hate it. I can't spell at all. That part of my brain doesn't work. Okay, here are flashcards for your convenience. Okay, boom. All right. And then let me know if they come through or whatever. But it'll be in that summer Vargas. Is that what it looks like when it comes across to y'all? Does it look like a group? I don't know if you've seen those emails, but every once in a while I'll email, like a mass email, and I've named it like Summer Trigonometry with Evan Vargas. Or it may just come from my email. It may look like it just comes from Sterling Mill, or S. Mill Holland. It'll take a second for it to load up. Cool. But are you good? Cool. Yeah. No, the name of the game is just learn identities. That's all it is. And then really it's